This chapter is called Memory Systems, and there are some points I'd like to make on memories, but most of the time we talk about control registers. When dealing with memory, we agree that 2 to the 10th power equals 1024, which we're going to call that 1K, and that 4 times 1024 equals 4096, we're going to call that 4K. And finally, one page is equal to 256 bytes. So one page of memory is 256 bytes of memory. Could be RAM or EEPROM or something else. If we begin counting from 00 to FF, we will have counted up to 256 bytes of RAM. That means that we've been operating on page 0. So in other words, the third digit of our numbering system is the page number. If we continue counting, then we will move into page 1. And then each time we go past FF, we go up another page number. Page 1, page 2, page 3, etc. until we get to FFF. If we continue counting past FFF, we will have reached the 4K page number because 1000 is 4096, which we agree we're going to call that the 4K page. So the fourth digit gives us the 4K page number. Control registers are 8-bit because the 6811 is an 8-bit microprocessor, but the difference is that each bit has a name and each bit has a function. The init register is a control register which controls RAM and registers and is located at hexadecimal 103D. Notice that the register is showing a bit pattern which in hexadecimal is 01, which means that the registers are located on 4K page 1. In this case, the registers are the ports, port B, port E, port C. And you can see that the numbers of each port are located on 4K page 1 because the fourth digit is a number 1. The same register controls the position of RAM. Notice in this case that RAM is located on 4K page 0 because the default position of the register is 01. So if you see RAM 0 or bit 4 has a 0 in it, that means 4K page 0. Let's say we want to move the position of RAM to 4K page 1. That means that the bit pattern for the init register must be 1, 1 in hexadecimal. We can write a short little program as shown. Load accumulator A immediately with 1, 1. Store accumulator A at 103D. So we have changed the bit pattern from 0, 1 to 1, 1. And so with great deal of ease, we were able to change the position of RAM. And in this way, we could change the position of other things too, simply by running a little program and then putting that number on top of the position of the register, in this case 103D. Sometimes the store accumulator A command can't reach so high up in memory. So in that case, we use index addressing mode. In this case, load index register X immediately with 1000. Load accumulator A immediately with 1, 1. Then store accumulator A at 3D, comma X. In other words, we're going to add index register plus 3D, which gives us 103D. That is the hexadecimal address of the init register. And in this way, we did the same thing. We changed the bit pattern, but using the index addressing mode because we're high up in RAM.